straightforward from the readings. Number one is asking about the range for the correlation coefficient between any two variables. What is a range?
No.
No. It was 1 and 2. Yeah.
Thank you. So it can be from negative
focus it
1 to 1. So if it's negative 1, let's say it's negative 1, what does this mean? It means it gives us an indication, or it implies two things. And what if it was positive 1? What does this mean? If the correlation between any two variables was negative 1 versus positive 1. And of course anything in between, but let's just take the extremes.
Slope.
And what do you mean by a positive or a negative relationship? What do you mean by that? So it tells us two things. It tells us a strength, like I heard here, strong relationship in a way, and certain one or close to the negative one. And I also heard something about correction, positive or negative. I just gave you a correction, so positive or negative. So what does it mean in the relationship between X and Y is X and Y variable. What does it mean the relationship with Y? And increasing X goes over to Y.
We need microphones on our tables. We need cool the buzz in.
So the correlation coefficient gives you two pieces of information. It gives you strength of the relationship, if it's strong, weak, moderate, and as if you read the slides, this can be a little bit arbitrary. These cut-offs between weak, moderate, strong, or these things, but you can tell subjectively how strong is the relationship, and it tells you the direction of the relationship as well. When X increases or the independent variable increases, what happens to the dependent or the outcome variable? Does it increase or decrease? If the relationship is positive, means both increase together or decrease together. If it's a negative relationship, if X increases, then Y will decrease. Number two, true or false, both correlation and linear regression analyses can be used to estimate or predict an outcome variable from one or more predictor variables. True or false? Any truths? False? Why is it false?
Because only the linear regression analysis is used to estimate.
So only linear regression can be used for prediction or estimation of Y from X. Correlation just tells us the strength and direction of the relationship, but you cannot use it to predict Y from X. And this is really important to know. Number three, which of the following is the most common statistical method or formula for calculation of correlation between any two variables? Okay, there are two Pearsons. It's Pearson's product moment correlation, and even if you see Pearson's correlation, that's still the same thing. If you even see just correlation coefficient, you can safely assume that this is Pearson's correlation because it is the most commonly used correlation coefficient in the literature. There are other ones that are being used in special cases. I will mention them in the slides, but these are very special, and if they are being used, the author will spell them out. Question number 4. The results of a simple linear regression analysis showed that the correlation coefficient between two variables was equal to 0.8. This means that the coefficient of determination for the same relationship is equal to
0.64. You do 0.8 squared.
The coefficient of determination is basically R squared. The correlation coefficient is R, so the coefficient of determination is square of the R, which is 0.8 square, gives you 0.64. What does it mean? I'll keep this for a little while unless someone want to really tell me what does it mean. What does it mean that the coefficient of determination is 0.64?
64% correlation.
So what does it mean for two variables, let's say, again, x and y, what does it mean that the coefficient of determination is 0.64?
It's a 64%
Anyone?
correlation.
She pointed to you. Oh, someone there. Ding.
It means that 64% of the dependent variable is accounted for. 64%. Something with variation is accounted for
He's doing correlation.
the dependent variable by the independent variable.
There you go.
Okay, thank you. You know, this is like on paper, you know, that's what I want to hear. I'm not sure if you really know what it actually means or how to explain it. But basically, what are we trying to do here? We're trying to predict y, right? So every time we try to predict y, it's even if in the same population, when we take different samples, it's not going to be the same, right? Every time it will have a different value. So there will be a variability in y, in the outcome, right? So when the researchers start their study, they have certain hypotheses that there is a certain factor or several factors that are causing y or are associated with y, right? So when we establish our model between x, let's say it's one factor, x and y, we want to know if that factor x actually explains the variability in y, what happens in y, these changes. Meaning that the changes in x causes changes in y. Because if you change x, like in any experiment, even if it's a lab experiment, if you keep changing x, but y does not change as a result of that, or it changes but unpredictably, what does this probably mean? Let's say even, you know, you give someone a drug and you're waiting for a certain response, and you don't see that response, or it's unpredictable, or it's not dose dependent. You would probably say either this drug doesn't work, or there are other factors that are combined with this drug that causes that response. So you want to know how much percentage in the response that you see is actually a result of the effect of that drug. Okay, so if you actually give someone, like ask them to drink caffeine, for example, and their blood pressure really increases very high, and you didn't expect to see that very high increase in blood pressure. You still expected to see some increase, but not that high. You would start to think, okay, maybe there are other factors, and of course that there are other factors that might be contributing to increasing this blood pressure. Your coefficient of determination for this relationship between caffeine and increased blood pressure is, you ask yourself, how much percentage in the increase in blood pressure is accounted for or explained for by caffeine itself? It could be 50% or 10% or 80%. If 80%, then it means that caffeine is a major reason for increasing the blood pressure, and then that's a good fit. That's an excellent relationship or an excellent model. If you get a coefficient of determination that is 0.1, it means that only 10% of the increase in this blood pressure is a result of caffeine. It means that 90% of this increase is not explained by caffeine, it's something else actually that you're not accounting for. That's what it basically means, and then we'll discuss it more as we go, but I just want to give you an idea. So the coefficient of determination explains how much percentage of the change in the outcome variable is accounted for or explained by the change in the independent variable that you're trying to establish a relationship with the outcome variable. That's basically the coefficient of determination. Any questions about that before I move? Okay, we'll visit it again and also during the applications. Okay, so what is the appropriate statistical analysis if you have one or more variables and you're trying to see their effect on one dichotomous variable? Logistic regression. Why is it logistic regression? There was a key word.
The key word was dichotomous.
Which kind of variable?
Binary.
When you see the effect of one or more variables on one dichotomous variable, so which kind of variable is a dichotomous variable? Is it an outcome or an explanatory variable?
Outcome.
It is an outcome variable. It is an outcome variable. Logistic regression is only used when the outcome variable is dichotomous. And I'm going to try to actually draw a chart here that's very important. It will eventually either come on the exam, and I ask you to complete some elements of it, or I might ask you application questions about what is the appropriate statistical test to use. Because this is the very first step when you're faced with a problem. When people come to you and say, we're going to do this type of research, this is our explanatory variable or independent variable, and that's what we're trying to predict, or the outcome we're trying to assess. What is the statistical test we should use here? This is the first step before you run anything. So let me try to do things here. So today we are actually talking mainly about relationships, right? Relationships between X and Y, or it could be actually not just one X, it could be X or X's, right? Because it could be one or more explanatory or independent variables, but we're gonna always talk about one outcome variable, because if you're studying more than one outcome variable at a time, that can be very confusing to, and if you're trying to study that. So we're talking about relationships between X or X's and Y. So the first thing is you could just do correlation analysis. And forgive my handwriting, I know it's awful. I think you can live with that. So correlation. Correlation is basically a relationship between X, one variable, and Y. And do they have any units?
No.
No, they do not have any units. So it can be anything. X can be the dose of the caffeine, which is milligrams, for example, and the response can be blood pressure, which is measured in millimeter mercury, right? So they are unitless. You're just trying to see if X increases, what happens to Y. And can you make any predictions or estimations of Y from X? No, you cannot. You cannot do that with correlation. Correlation just tells you that there is an association between X and Y, and it tells you two things. It gives you correlation coefficient, R, which gives you two things. It tells you the strength of this relationship and the direction. The direction can be positive or negative, positive or negative. And the strength can be anywhere from -1 to +1, as we said, and the closer it is to +1 or -1, the stronger. And it doesn't matter if it's negative or positive, which actually will bring us to the next question in a minute. So that is correlation. Do we do correlation for categorical or continuous variables?
Either one.
What do you think? When we draw a line like this, what does that mean? It means that they are continuous variables. So correlation is the same as linear regression, but just we cannot predict or estimate y from x. So we do it for continuous variables. So x and y should be continuous. And I hope that you all know what continuous means. So it's all continuous variables. And then we have two other options. We have regression in general here, regression. And in regression, you can predict y from x. And there are many types of regression. First, there is linear regression, and then there is logistic regression.
Dr. Shoyer,
Yes, ma'am.
this is still X?
Sorry?
Is this still X? We're working on X. Or we
We're
have-
still comparing x and
X.
y, yes. But what I'm waiting to define x and y according to each type. Is that what you're asking?
Where we went from, are we still working on the X's, like it from the top? Does that make sense?
You mean here?
Yeah, the regression.
I'll mention x and y in a minute, depending on which specific regression we're gonna
He's not
do. So when
just
we reach
X.
simple linear regression, I'm gonna start talking about x and y. Just hold on for a second, I might answer your question.
Okay.
Okay, so we have linear and logistic regression. So in linear, we have two types as well. We have simple, hold on, I'm gonna answer your question, and multiple linear regression. And the same for logistic. We have simple logistic regression, and we have multiple logistic regression. So in simple linear regression, there are only one x variable and one y variable. So one x, one y. In multiple linear regression, there are multiple x's. So I'm going to just say x's because it could be more than one, and there is still one y. Same applies to logistic regression. Simple logistic regression, one x, one y, and multiple is x's, which means more than one independent variable, and still one y. It's really easy if you think about it systematically. What determines which way of the four we go is the nature of the independent and dependent variable. If the dependent variable is a dichotomous variable without thinking, it has to be logistic regression. What do we mean by dichotomous variable? Can anyone tell me? What is an example of a dichotomous variable?
Two categories?
Male and female, you know, two categories, three categories, doesn't matter. Sorry, that's actually two categories. Dichotomous variable, it has to be two categories. So male and female. So any dichotomous variable, meaning that we're using logistic regression. But still, there are simple and multiple logistic regressions. So how can we tell? It depends on the number of predictor variables. If we have one predictor variable, then we do simple logistic regression. If we have more than one predictor variable, then we're going to do multiple logistic regression. In both cases, y has to be dichotomous variable. So in both cases, y is dichotomous. How about x? X can be anything, so don't even memorize it. It can be dichotomous, it can be continuous, it doesn't matter. So all your focus is on the nature or the type of y. When you look at x, you just focus on how many variables are we assessing. If it's one, then it's simple logistic regression. If it's more than one, then it's multiple logistic regression. But in both cases, the outcome still has to be one dichotomous variable. Is that clear for logistic now? Any questions about the logistic regression? Okay. How about the linear regression? The only difference between linear regression and logistic regression is that the outcome has to be continuous. It cannot be dichotomous. So the y here is continuous. And the y here is continuous as well. Again, how about the x's? The x's can be anything. They can be anything. So that is basically the chart. So if I'm faced by any application, here's how I'm going to think about it without even looking at the chart. I'm going to say, what are you trying to establish a relationship between? Someone tells me, well, two continuous variables, then my thinking, like an independent continuous and outcome continuous variable, then I'm going to start thinking about correlation and linear regression. I'm not going to include logistic at all in the equation if the outcome is not dichotomous, right? And then I'm going to ask the next question, I'm going to ask, are you trying to predict y from x? If they say yes, then I'm going to have to go which route? The linear regression, because correlation cannot do that. If they said no, it doesn't matter, then you can't go wrong with either way. You can do correlation or linear regression. Okay, let's say we settled on linear regression. Now I ask them one additional question. How many variables, how many independent variables do we have? Are we trying to establish a relationship between just caffeine dose and blood pressure, or caffeine dose plus, let's say, the time of exercise or the duration of exercise and blood pressure, so two variables. If it's one variable, then it's simple linear regression. If we have more than one x, then we have to do multiple, as the name implies, multiple linear regression. Now, a different application is, someone comes to me and say, well, I want to see after surgery, if you remember the paper I gave you at some point, after surgery, if people develop cognitive dysfunction, if they experience cognitive decline in their memory, for example, that's a dichotomous variable. It's yes or no. They will have cognitive decline or not. That's still a dichotomous outcome. It doesn't have to be a certain classification of male and female. So it's a dichotomous outcome, that it's logistic regression. The question now, is it simple or multiple? Again, I ask them, how many independent variables do we have? Are we trying to see the effect of one variable or more than one on having cognitive decline after surgery? If they say just one variable, then it's simple logistic regression. If they are trying to evaluate the effect of more than one variable on that dichotomous outcome, then it is multiple logistic regression. Question?
I think you answered it.
Thank you. Any questions about that? Any questions? Okay, sounds good. Because I am going to have an application or in the exam, you know, I don't think I will use a chart, to be honest, maybe, but you know, not necessarily. Probably it's going to be an application. I'm going to propose you with an example. I'm going to, for example, I'm going to, you know, give you a hint. I'm going to ask you, well, we have been trying to do this study, and we were trying to assess the effect of age, gender, and the dose of that drug or whatever on blood pressure, and what is the type of analysis we should use here? Can someone answer that? We're trying to assess the effect of age, gender, and a certain drug, taking certain drug on blood pressure. What is that type of analysis?
The dependent is blood pressure. And so it's multiple linear, right?
So you said the relationship between age, gender, and
Taking a certain drug on, taking it or not, on blood pressure.
okay, that will be multiple linear.
Thank you. Perfect. Thank you so much. That is multiple linear regression. Why did you choose multiple linear regression?
Because you have just one outcome you're looking for, and you have multiple independent variables.
Well, the first part
It's
is
continuous.
still missing something. It doesn't. In all of them, we have one outcome variable. But what's the nature of that outcome variable?
Continuous.
It is.
Continuous.
Say that again.
What's the nature of that outcome variable?
It's continuous.
Continuous. Okay, because how do we measure blood pressure? Blood pressure is a number, right? And we measure continuously. It's not yes or no. It doesn't have any categories like that, right? So that's multiple linear regression in this case. And I'm gonna make it clear. Sometimes it will, be very crystal clear the nature of the variable, and sometimes if it's a little confusing, I'm gonna give you a hint about how it is classified. Because I have to tell you something. Sometimes it's a little bit tricky. So let's say someone was trying to measure. I expected actually someone to ask me this question. Some people try to classify age or blood pressure, right? So instead of measuring it on a continuous scale, they say, we're going to actually classify it as, first category is 80 to 120, and then 121 to 140, and then 141 to 160, and so on. Let's say they had two categories only in this example, and then they want to know the effect of caffeine consumption on having from 80 to 120 normal blood pressure, or 121 to 140. In this case, this is a categorical outcome, a dichotomous outcome. This is no longer a continuous outcome. But unless I said something specific like that, then you should not assume that it is dichotomous. By nature, age is a continuous variable, right? Blood pressure is a continuous variable. The dose of a drug is a continuous variable. These are all measured on a continuous scale. Unless I specified that it was classified in a different way, then you should not assume that this happened. Okay? So this is really important, than all the details that we're going to discuss now, because if you don't know which statistical approach or method you're using, the rest doesn't matter. So I hope that you, again, make sure you look at this chart, again, with my awful handwriting, and just try to decipher it, and see which, give yourself actually an opportunity to kind of bring up some examples of an application that you would use in each, or that you would use each of these statistical analyses for. And today, actually, we're going to have plenty of them, but the thing is, the ones we're going to have today are going to all be linear regression, since this is the nature of our class. But next time we'll discuss logistic regression, and you will see more of it. Okay? So let's move on now. Which one of the following correlation coefficients indicate the strongest relationship between two variables? Oh. So which one? A, you want to answer A? Okay. B? No? C? C? I answered C. Okay. Anyone answer D? D, okay. So the answer is actually C, but I'm surprised because it's negative 0.6, which is smaller than 0.5. I'm not sure why did you pick negative 0.6. Can anyone tell me, please? I'm actually shocked.
Closer to -1.
Why negative 0.6?
Because it's closer to -1 than the positive values that are closer.
Oh,
So negative 0.6 is closer to -1 than 0.5 being closer to a positive 1.
It's just directional.
So it has a stronger relationship.
Thank you. So what I'm hearing here is that the sign doesn't matter when we're talking about strength. Is that what you meant? Is that what you meant, that the sign does not matter when we're talking about strength?
Right.
Okay, so yeah, that's true. So the strength, when we're talking about strength, the sign does not matter. So in this case, we're looking at the number without the sign. The sign just tells us if this relationship is in a positive direction or negative direction, which is a different aspect of correlation. It has nothing to do with strength. Which of, based on this example, a relationship between x and y resulted in a correlation coefficient of 0.789 and a p-value of 0.01. So which of the following statements will be true about the relationship between x and y? First, is it statistically significant or not significant?
Yes.
It is significant. And why? Because the p-value is 0.01, because any statistic, even the R, has a p-value and a confidence interval that get calculated with it. So the p-value here is less than alpha, which is in the nature it's 0.05. So in this case, it is statistically significant. And is the direction positive or negative? Positive, because it's positive sign. Okay, number 8, what is the slope here? This is a linear regression equation. What's the slope? What is the slope for this linear regression equation?
0.0180.
0.0180. What is the intercept?
Negative 0.0127.
Negative 0.0127. Okay. Can you tell me what exactly the slope means here? Like, what does it mean that it's 0.180? What was X? Can you tell me what was X to start with? What was X representing? Can you say that number, please?
Number of beers consumed.
Numbers of beers consumed. And what is Y?
Blood alcohol content.
The blood alcohol content. Okay, so based on that, what does the slope mean here?
Number of dependents change. The number of dependents change.
The number of what, sorry?
Dependent variables.
Dependent variable. I know it changes. Thank you. I know it changes, but in what way? So for each unit increase, whatever the unit was, for each unit increase in the number of beers consumed, how much increase are we going to see in the blood alcohol content?
So for 1 unit, there will be a 0.018 units rise in blood alcohol.
Thank you. So this is the way we spelled it out. For each unit increase in X, which is the number of beers consumed, there is the amount of the slope, which is 0.0180 increase in the blood alcohol content. So let's say someone consumed 2 additional units of beers, then we're going to multiply 2 by 0.0180, and that will be just the amount of increase in blood alcohol content in this population. This is just the additional increase, not the total. Okay? If you want to calculate the total, then you're going to have to calculate the whole equation. We're going to see this in a minute. Okay, so that was our discussion for the TRAD. Now let me post the application that we're going to use on Canvas. And as usual, if you need a break or something, feel free to go, but we're not taking a break officially. We're going to work on the applications like every time. I will need everyone to turn in their individual application, but you can still, of course, work with the team, ask for their help, clarify any questions from the team or from me. Please don't be stuck. Okay, I just posted the applications on Canvas. Check them. As you will see, the first thing you're going to do is open this website to use for entering the data and calculating the linear regression. So this website is actually really easy and straightforward. This is your x variable and this is your y. If I were you to actually understand the problem, name them. Name your variables. So see what they are actually named in your problem or application. For example, here we're talking about x is the weight and glucose is x is the weight and the glucose is the outcome variable. So I would just remove x and write weight and write here glucose level. And then I would start entering the data. This is like Excel. You can enter the data, press enter and move to the next cell or move to the right and just enter your data, and it allows you to enter up to 100 observations or 100 subjects. And once you're done, Let me try to just, write the fake numbers, or at least a subset of it. You can try with me too. Okay, I'm just gonna use these and run the analysis just to show you what you get. Okay, perfect. So first of all, you're gonna get, this is not of course the actual solution, but you're gonna get a straight line, a relationship, a linear relationship between weight and glucose level, as you can see. And then for this relationship, if you scroll to the end, you're going to see the linear regression equation. So if I ask you about the linear regression equation, this is your linear regression equation. As you may have noticed, it's actually like flipped. So they start here by the slope. Whatever is close to the x variable, that's your slope, and then they put the intercept at the end. So this is your actual slope. And then what else do we have here? So they have r squared. What's r squared? This is your coefficient of determination. R squared is your coefficient of determination. So if I ask you about that, that's your coefficient of determination. If you want to talk about it, like how much percentage in the variability in the outcome is accounted for by x, you can multiply it by 100, it will be 40%. And what else do we have here? How do you determine the statistical significance? Statistical significance of this relationship. There are two ways. Let me see what they have here. Okay, so this is a p-value. Look at this p-value first. It will tell you the statistical significance of the relationship for the slope. In this case, for example, it's 0.36, which is not statistically significant. That's one way. And then there is a confidence interval as well. So if you look at the slope here, this is a statistical significance. Using confidence interval, it's negative number to 0.76. Let's go back to the linear regression equation and look at the slope. And I want to ask you a question. This is a slope. What if this slope was 0? What would result or would happen if the slope is 0? If you multiply 0 by x, what do you get? 0, and then y will be just equal to the intercept. So there's no relationship, right? There will be no relationship. So what would you think will make you say if the relationship is statistically significant or not based on the confidence interval for the slope? If the confidence interval for the slope contains 0, what would it mean?
No difference.
It would mean that it's not statistically significant because it is possible that the slope would be 0 at least one time, right? So if that's a possibility, then the relationship is not statistically significant. Now see, we're thinking about it logically with each other without even memorizing anything. That's the way you should think about it. So if I ask you to determine statistical significance using two approaches, I want you to tell me what is the p-value, and if it's less or more than alpha, that's one approach. The other approach would be using the confidence interval for the slope. If it contains 0, then it is not statistically significant. These are two approaches, and they should coincide. So they should actually make you conclude the same thing. If they make you reach two different conclusions, then you're thinking wrong. Okay. And,
which confidence interval do we use?
From the coefficient of determination, the r squared, can you calculate r, the correlation coefficient? Yes, you can do that. You can just take the square root, and that would be r. That's mainly everything that you're going to need. No leaving today after you're done, because you still have to go quickly through But once your team is done, the whole team is done, please let me know, okay? And turn in your applications. No, just I'm gonna use scratch paper, you can use scratch paper, okay?
I'm done. Yeah. What's number 2? The correlation coefficient. And which one is that?
R square. Wait.
No, it's the
That's
square
That's the
root.
other one. It's the square root of that, yeah.
That's right, that's right.
Because that's the correlation of differentiation or something.
So what did y'all get? 0.48?
For which one?
0.48.
Do I need to take it out any further than that, or do you just do 2 decimal places?
I don't know.
Dr. Schreier,
Yes, ma'am.
on the correlation coefficient, how far out do you want us to take the decimal places?
That's a good question. Just 2 numbers maybe.
Just 2?
Yeah, just 2 numbers. So for the correlation coefficient or coefficient discrimination, 2 numbers, 2 digits are okay. So when you round, 2 numbers are fine. Just like one. Doesn't matter, you know, I'll get it. Don't worry about it. But just 2 numbers are fine.
You get 0.5098 plus 61.88 for the
Which one?
the equation.
0.5098? Is that what you said?
Yeah,
You
plus
said X
61.88.
Did you calculate that, or did you just use the equation on the
I
thing?
use the equation, I think.
Okay.
What'd you get?
It's at the very bottom.
5099x plus 6187.
Maybe we entered it. Did you enter one of them wrong, maybe?
You got, what did you get?
I got the same thing. He got the 0.5098x plus 61.88. So
guess
it
I
might be
did.
that one of your variables got off.
Oh, and that erases it. Let me go back.
Yeah, it's annoying.
Okay, so test if the relationship is statistically significant. So does that mean like the confidence interval and the p-value? Is that what it means?
Yeah.
Did you really think that? Good. You're so good. I'm not gonna keep flipping back and forth. Do it. I'll be up here till tomorrow. Yeah. I was gonna say, take a picture of the data. That's what I do. Take a picture of it and then just look at the picture. But I agree, papers. I always like papers.
You write down my thoughts, then I take a picture of it. When I need to be there.
So for number 3, testing, did you just use confidence interval and p-value?
Yeah, it's not bad.
Okay.
And our alpha should be 0.05.
Yeah, because we assume it, right? And we're saying it's not statistically significant, right?
Yeah.
What is your p-value? 0.574?
That's all.
And what's your confidence interval?
Confidence interval.
Is it the slope one? The range? The slope range? Is that what we use? I mean, there's 3 of them, but I would say you use the slope one, right?
Well, it has, or it can be the x-intercept. It has to have 0 in it to be.
Not to match up with the
Yeah.
p-value, right? That's why I was thinking the first one is a smaller range rather than infinity. Because if you think about it, x and y are just on the thing. I think
And that's
the
a
slope
relationship
is, yeah,
between x and y, the slope.
exactly. So I think we use the slope value for our confidence.
Okay.
interval.
Makes more sense. 0.574.
Mhm.
How much of the variability is explained by the relationship between body weight and blood glucose?
The p-value and the confidence interval. You have to use two tests.
Are you gonna put 23.44% on number 4?
I
23.4, yeah.
Okay, so y'all talk
Is
me
that
through
what-
that one.
That's just the R squared value. It
And
tells
the
you
percentage.
how much the relationship between these variables is actually pretty much able to explain.
So that's what the R squared value tells us?
Yeah,
The percent of variability?
yeah. It tells you
Okay,
how
so
much
can I
the,
get your attention for 2 minutes, please, okay? Just to clarify 2 concepts. We don't want to start or go through over the slides first today, but let me clarify 2 important concepts for you as you go through the application. So, let's say again, going back to the coefficient of determination. This question is asking how much of the variability in blood glucose level is explained by the relationship between body weight and blood glucose level, which is the relationship you're trying to establish here. And blood glucose is the outcome variable. This is basically asking you what is the coefficient of determination, but I want you to say 1 full sentence about it. So again, in this example, what is the coefficient of determination? We're again trying to establish a relationship between weight and blood glucose. I will ask you all one simple question. If weight was the only determinant of blood glucose level, how much percentage do you think R squared would be with the coefficient of determination?
100.
What would be the coefficient of determination if weight was the only, as if we know that this is a fact, that weight is really the only factor in the world that affects or influences blood glucose level? The R squared would be expected to be 1. And what would that mean for 100%? What would that mean? It would mean that 100% of any variability, any changes in blood glucose level is accounted for or explained by 100% explained by weight. There is no any other explanation. There is no other factor that contributes to this change in blood glucose. But in reality, we know that this is not true, right? We know that there are other factors that contribute to increase or decrease or any changes in blood glucose level. So when you're trying to solve this problem, I don't know the answer now, but my expectations is that the weight is a big factor, but not everything. You will find that R squared may be something like, let's say 0.6, for example, just hypothetically, or 60%. And in this case, I'm going to conclude that 60% for the variability in blood glucose, the outcome or the changes in blood glucose, is accounted for by weight. How about the other 40%? It's accounted for by some other factors that I do not know. That's what it means. And it means that you have succeeded in kind of pointing or putting your fingers on one of the major causes or the major factors that are associated with the changes in blood glucose, because it constitutes 60% of the variability in the outcome. Is it clear now? You will never see probably R squared of 100% because there are always other factors involved in the relationship or can affect the outcome. But the closer this to 1 or 100% means that you have actually identified one major factor in this relationship. Okay, is that clear? So when I ask you how much of the variability in blood glucose level is explained by this relationship, you just give me the R squared, which is a coefficient of determination, change it to a percentage, and say how much percentage in of the variability in blood glucose is accounted for by this relationship. Okay? Sounds clear? There's one more thing. When I ask you to predict y from x using the equation, I'm not sure if you read it, you probably read it, it was in the article, and I'm gonna go over it in the slides too. Although it might sound mathematically plausible to you to use any number and plug it in the equation and reach an outcome, if I'm asking you to predict a blood glucose level for a man who weighs, let's say 100, is that in pounds or? It doesn't say actually, right?
It's in pounds.
Kilograms, no, kilograms. 100 kilograms. Can you do that?
I thought you said bounds.
No, you cannot. Anything, any value outside the range of your data, you cannot just plug it in the linear regression equation and make an estimation or prediction because you have not studied that. You can make any estimation within the range of values. It doesn't have to be the exact value in the table, but within the range. So see what is the range, which is a minimum value and maximum value in the table for x. Any value in between those is fine, but any value below the minimum or above the maximum, you cannot make any predictions. And even if I ask you to predict the outcome for a value like that, you should tell me no, I cannot do that because I cannot predict outside the ranges you have given me. And the reason is, sometimes again, mathematically, it might sound okay, but it doesn't mean even anything. I'll give you an example. If I was asking you, remember in the article, it was making a relationship between body fat and number of injuries, right? For the players, correct? Can I say I want to know the number of injuries for someone who has a body fat of 0? What does this mean actually? What does biologically mean someone who has 0 body fat? It doesn't make sense, but it still will give you an answer, right? Even if you plug 0, it will give you actually a number of injuries for someone who has 0 body fat. So you cannot always generalize outside the range of values that you have. That's all I want to tell you for now.
So did you have
Working?
17.762.
Yeah, I just rounded to 8.8. And then how did y'all phrase number 4?
Wait, what did you give for 5?
107.8.
107.8. I rounded mine. It's like 0.76,
Yeah.
but I just rounded to 0.8.
I just put 23.44% of the variability in blood glucose level is explained or is accounted for
Due to body
by
weight.
the, yeah.
Okay, thank you. I was having troubles formulating that one.
107.6.
Now it won't clear the freaking chart. Now it won't clear all the results now for me.
Did you go back?
3.
Mine cleared. Oh my.
I kind of wish it would clear now. I gotta go through and delete everything.
Did he give us a sheet of paper? Or are we filming
Yeah.
this?
No, he gave us this.
Oh, did he? Oh, he just gave us that. Well, didn't he say something about we needed to turn it on?
Is it individual?
Individual. But he said let him know when our team is done.
Oh, okay. Gotcha.
Mine did. When I went back, it
Just go
cleared it.
back? Okay.
I just re-entered it and hit the delete key on everything.
Oh, okay. If you go back to enter data, it clears everything out. So I don't have to go back.
Did y'all enter the second one?
Yeah.
You
I
get
haven't entered it yet.
y equals 0.4451 plus 112.3.
Yes.
Y'all just do an age and blood pressure. Like,
Mhm.
y'all aren't doing units or anything like that.
Yeah, because blood pressure is independent, so they go on the y-axis. Or wait, did I do that wrong? Isn't X the dependent?
X is independent.
X is independent?
Y is dependent.
Okay, I'll make sure I
X,
got that
X
right.
is the age.
You solve
Yeah.
for Y, so Y is the dependent variable.
That makes more sense.
Don't forget your units on the number 5.
Okay.
Wait, it didn't give the p-value.
23.
It didn't give me a p-value.
It didn't?
It just said
Less than.
that it was less than.
Oh, well, that's it. It's too small to account for.
And just to make sure I put everything in right, for the equation on number 2, 0.4451 times x plus 112. Right?
Yes.
Make sure you put y.
is.
And then y'all got 0.97. Is that confidence interval? I mean, not confidence interval.
Confidence coefficient. Or correlation.
Yeah, that one.
The p-value is less than the alpha. Remember, alpha is always 0.25. So if the p-value is less than that, then it is statistically significant.
We're rejecting it.
Yes. When you reject something, it's because there's a difference. There's a significant.
Do you say correlation instead of difference on this?
Huh?
You think you need to say correlation instead of difference on this?
Okay,
It's kind of what gets me.
right.
Where?
Like, since we're doing correlation instead of difference, so we're not comparing groups.
I'm not using difference at all.
I just said correlation.
I just said it is statistically significant because 0 is not in the CI and p-value is less than that.
That's a good way around it.
It's a thick read, though. Talking better than you. But I think we're gonna use it for I actually think it was I wish we could get these back sometime. When most all the kids out there, we never get a feedback.
The questions are all the same, right? I didn't even look at that.
For the second one, yes.
Yes.
I haven't looked at the third one. Why can't they just be whole numbers? Yeah. They should have just measured them in kilograms.
Did y'all get 128.8 or 20.76?
Yes. For number 5?
Yes.
So for the third one, they added a question. Are you on the third one already?
Oh no. No, I am.
Oh, I really need 10 key, guys.
You need who?
10 key.
Okay.
What is number 3? Is the one that he has?
Yep.
Oh, he asked what the strength is.
Then you want like a positive.
He wants to know the British stuff.
Very weak correlation, moderate correlation.
0.8. Is it ready?
Yep.
I think I used the wrong number. Before, which number did you use for number 4? Number 1.
23.44%.
Okay, I did too, but now I'm asking myself, why didn't I use the correlation coefficient?
Because you need to use R squared.
Yeah, R squared.
Remember
No,
up there, R
to
squared?
answer number,
Yeah, number 4. So that's gonna be your, it's asked you what, how much of the variability is due to the other thing. That's your R squared.
In a percentage.
Yes. Like up there, what he was talking about. Blood glucose, the change in blood glucose is due to weight by the 60% of the R squared value.
I'm still trying to get the numbers I can read. It's the except for the test. I'm asking myself,
Why is the R squared value that?
being used when I'm thinking the correlation coefficient, well, that's no correlation. It's just something I have to separate before I get to this test. Okay, because or is it gonna give me a number and it's not used to predict? Okay. This is basically asking me to predict something. Okay. To predict I use what is that square called again?
Coefficient of determination.
Thank you.
But see, when it says how much is it accounted for, it's the R squared and a percentage. If it asks for how much is not accounted for, you subtract the percentage from 100.
Okay. Okay. Did it ask me that yet?
No, not yet, but
Oh, it's
just
not.
if it throws it at
Oh,
us.
okay.
Do I get 0.82 number 3?
Yes.
Put the variable of the blood pressure count for by age.
So what number do you use to determine strength of formation?
The strength
The-
is
I mean,
R.
I know we talked about the -1 to that, but what, is it your R value?
Yeah.
Okay, so you use the 0.82.
Yes.
Okay, thank you. That was my question.
But you're answering which one? Number 3, right?
In your opinion, yeah. Yeah, that's the ranges. Yeah, I gotcha.
Am I giving you the test? What makes you think I know that? I don't know everything. I would hope you would give it to us. But if you want to remember it, it's increments of 20.
Yeah, it's 0 to 4. That one. The back.
0 to 0.19, 20 to 3.9, or 0.3.
We can't predict that. That's what you put. Oh my God. That's the ID. Age. Yes, and no, I can do it.
How many are there?
It's the input.
I ask about the goodness of fit, please pay attention for a second. And again, we're gonna review that in the slides. When I ask about the goodness of fit, the goodness of fit, that's a term that we use for R square or coefficient of determination. The goodness of fit or the lack of fit of the model both mean the same thing. It basically means again how much percentage in the variability in the outcome variable is explained by or accounted for by the relationship. So it's the same like the other ones, the R square, and then you just explain it. That's the goodness of fit of the model. How good it is, how good is this relationship, how good it explains any variability or a change in the outcome variable.
The same way you did. Oh. You're ahead of everybody else.
And you know you're ahead of me.
Plus, what did you answer for number 6? You can't do it. Why are you looking at me like that for? No, you can't do it. What is the low? What is the lowest weeks that we have? No, that's not the lowest. .3, and what's the highest?
How do you do application 4?
41.
No. Okay, so we can only predict the data between 29 and 42. You can't predict anything outside of that. So we can't predict the birth weight at gestational.
Because he said even though it never.
Did you do that too?
No, I'm still on it,
On which one?
On number 6 of app 3,
What about it?
we can't predict the birth weight.
So is our lowest value not?
Our lowest value is
I got
29.3.
you. Right.
Wait, so how do you add more wives?
I don't know. Do you just like extend it out? I don't get it.
So did y'all word it? I just said this cannot be predicted due to the gestational age being outside of the reported age range of
Yep.
the data.
I don't know how to do number 4. Or application 4.
31 subjects. guess choose a calculator. Would this be a linear regression?
Okay. How do we do this?
Well, that's what I'm asking. Is it a linear regression? Because if so, you can choose a different calculator.
This has to be a multiple.
He said that they're all linear. Is that what you're asking?
You said they're all linear.
Yeah, that's what he told us today before we started.
Yeah, for multiple. Let me try changing the calculator.
How do you change it to multiple linear regression? It doesn't give you an option. Because I'm not going to sit here and enter 1 and 9, 1 and negative 1.2, 1 and negative 1.2.
Well, I guess look at the question.
It'd be 31 times 4. Or 20,
Yeah.
124 data inputs.
How do you do number 4 with just calculator? Is there a way to put in more variables or?
So basically you're doing H as the independent variable with each of these independently as an outcome. Each of these variables.
So 31 different ones paired with
Yes, like 30 actually, not 31.
31.
Okay, 31 paired with each of these outcomes independently. So you're going to enter H with each of them separately. And then reach a conclusion for each.
So this is like a 3-problem problem.
Dr. Shaw, is this graded on completion? I'm trying to think all the way through it. So.
That says just busy
You
work.
don't have to do 3 different ones, do you?
Yes, huh?
That's what he just said.
I heard him say the other two, but
Yeah, that's what he just said. He said you have to do age paired with each of those 4 numbers.
Oh, this make me too slow. 12, 9, 10.
But you're gonna have to enter in all of that data.
3 different times.
Yeah.
Crap.
Busy work.
You can copy and paste.
Oh my god. Y'all don't even want to see the next one. Look at number 5.
Oh no! I give up. I give up on life. I give up on life. I'm just gonna become a refrigerator repairman.
Alright, let's do this. This is just taking me liking it over. See, how do you set Y? So we're just gonna have to enter in this data 3 different times.
Yep, you got it.
Oh boy. Hope I didn't make a mistake on that. Is he asking?
well, the one started. I watched one and two in between. I didn't eat. It was the pivot. It was, and then finally, I shut it down because they were touching. When she was there after two.
Why is my enter button not
So we're gonna have really 15 questions, huh?
Pretty much.
So 'cause for each column, we're gonna have 5 questions. Okay. Oh, thank you. No, you're good.
Well, good news is we only have to change the Y values.
Yep.
Your X value doesn't change. So you only have to update the Y set.
Oh, I thought you said the thing you don't have to change the line. I said, girl, I've been doing that all the time. Don't lie. So X don't change.
Yeah.
Here we go.
In number 5, application 5, number 1, I was just telling you to perform the analysis. You don't have to report anything, you're just performing it. And then do not calculate the goodness of fit for number 5, because in number 5, it doesn't actually make sense to calculate the goodness of fit, because we're just establishing correlation, but there's no need to calculate goodness of fit. For number 5.
What kind of garbage is age and HYP? The second one is just like awful scatter plot. It's almost completely horizontal.
You have to do all 3 first.
I'm just writing down all the info.
In the first APT, and at the beginning.
We could each do one. It would go faster. I think most everybody's through would have one.
Negative.
.1462x minus 1.061.
Yes.
Which one?
0.1462x.
I didn't get that.
For the first one?
Mm-mm.
That's what I got.
Did you get
That's what you
31
got too?
pairs?
Huh?
I was asking Bryce if he got 31 pairs of XY for that first one.
I have no idea. I probably fucked up on something. 0.1462? I'm about to rip this paper in half. God, this is fucking annoying.
We get the gist after doing the first one.
So there's not really a question to answer in one, right? You just start with two. Yeah. So yeah, there's nothing wrong with four on bullet journal.
Yeah, so many of these are so close together.
Hope I didn't screw that one up.
But how you gonna compare if you don't answer?
Is this for this first or second part right here?
What's that?
Is this the first part of 4?
I'm just writing all the data for,
That's what I'm doing, but is this the first comparison?
yes,
Oh, okay.
the ATT.
What'd you get for the second one?
I'm not done.
I don't trust mine. I'm apparently dyslexic or something.
I'm about really low.
I'm just writing it all at once.
How do you write it all at once if you don't have the graph, the information?
No, I'm writing I'm doing one and I'm writing everything for it. I'm doing the next one, writing everything for it, and then the next
What are you
one, writing
writing? You
everything.
say I'm writing everything.
Like p-value, r-squared, confidence interval. Because we gotta have the data to answer all the other questions.
Yeah, that's, okay,
Which bullet point are you asking?
Okay.
Because
number
none of
one,
them,
I got the second one
to
already.
determine if there's evidence to indicate the age.
it's just telling you to perform one for each of the three
Oh,
different.
just like complete, it's
Yeah,
not
exactly. It's like a done thing.
done.
Yeah.
Okay. Thank you. And so number two.
I guess I messed up on that one too. How am I so far off? Is my calculator broken or something?
Are you done with the second one, Lindsay?
No, I just got done with the first one.
How does your graph look?
I must be dyslexic. Jeez.
I'm gonna be cross-eyed after looking at this. Yeah, ours looks very different.
This is the third one.
Oh, that's the third one.
Yeah. Because the second one I knew I screwed up on. Because I screwed up on the first one. I'll just scrap that.
So this is what I'm doing is the second one.
Yeah, I didn't do that one. I got
So why are you saying why?
0.01334 for the second one.
Oh,
The ATT.
I really messed up on that.
What is it asking? I did not.
Report the correlation coefficient for the relationship.
I did, yeah, 0.4.
for which one?
Okay, thank you.
4826. Yeah.
Okay. Oh my gosh, you do have to re-enter all of your data.
Yeah. I'm gonna do the third one, Bryce.
Oh, yeah.
Make sure you're good.
I hope so. Dyslexic.
I want you to go back and triple check your values.
I got it wrong
Don't
twice in a
type in
row.
all of that mess.
Fuck.
You got significant number four. That's how you put, I just put significant.
Oh, you know what will help me out, Bryce? Are you doing something right now? You can read them off to me.
Read them off.
I'm just kidding.
I'll probably mess up on that. This is confusing.
Coefficient of determination is displayed. So 18.5%.
Who the hell is on number 5?
Yeah, I know, that's what I'm screaming. They divided and conquered, you didn't do it yourselves.
And if one of them got
So
one
just-
wrong, they all got one. Y'all know what they said about that.
Try to finish by 11:30, so we have like half an hour, so we can go over the slides quickly before we leave.
90 something, what is it, 90?
He said try.
You got 18.53%.
What?
Report the coefficient of determination.
If we all don't get the same thing on the third one, I'm just gonna give up.
I forgot. What is it? Oh, it's just all is the coefficient Right. Okay. So what was the other question asking?
Something about percentage variability.
Okay.
Is it a negative one? Oh my god, I'm stuck.
And report comment on the
0,
topic.
5. Wait, I messed up on that one too.
Oh, that's the same thing, 18.3.
I mean, I could be wrong too, but
It says and comment on the goodness of it. That's fine.
So that'll be a percent.
Yeah, according to this is, it's R squared equals to this.
Bless you.
Okay. That's what I got. This is the third time I entered it, that's what I got. God, I'm really starting to think I'm dyslexic over here.
Okay, so for the HYP, 0.003999 times x minus 0.4866.
yes.
Yeah.
Okay, thank you. Not common.
Or
The R squared rooted thing.
0.01.
Yes. Oh yeah, I'm struggling.
If you were 18.5% of the variability in ATT can be explained by the relationship between age and ATT. Number 5.
For ATT or HPT?
ATT.
I got 15.92. What did you get for 4 or the percent variability on ATT?
15.9%.
I got 15.
It might be that one of your things was different.
R squared, right?
What's your R
Percentage.
squared value?
My R squared value is 18.
Okay. Something must have been different.
We both put it in.
What did you get? R squared for the first.
Did you get the number?
Yeah. She got 50 from 50.9.
You can stop just shaking your head saying, yeah. And I asked you something. I'm blue. You wanna know why I'm blue? She said, yeah. I'm like, okay, I'm good. Let me keep going. Cause I heard y'all checking with each other. So I was like, okay.
What did you get 18 for? The R squared?
Yeah, my R squared was 0.1853. What's your name? Me too. You can stop saying, never mind, because she missed when I asked the question.
I have a number close to that, but it's the confidence interval.
Okay, maybe I wrote down something. Y, what was the equation? Y equals, see, my Y equals
Oh. What would you got? 14.
0.1568. I got my Y.
What should we 1064 003
I would say skip it. You did the work.
466.
Okay.
Granted, mine are numbered differently, but I mean, it just goes into
The
the
coalition.
page over there. It's easier.
Okay, thank you.
Coalition.
When you do that percentage, it's 0.01039%, right?
0.010.
Okay. Just making sure I'm moving my decimals over and
Is that, which one does that answer? Number 5?
yeah. For the HYP.
put in for the goodness of fit. Common
I think it's just
fit.
presenting what we do.
I'll laugh. Let me just read it.
The goodness of fit is just, I think, the percentage that the one we did, like the
But that's what the
variability.
coefficient of determination is. Please report the coefficient of determination.
Here, take. So this means 15% of whatever.
Maybe this is the same thing. So we gotta do this separate.
No. 12 minutes? I'm not sure if that.
Is it?
Number 4?
No,
No, number 4 is,
the difference between
that's the p-value and the confidence interval.
Y'all know what I'm gonna do? For the parents, I'm just. I got this. My bad. This is the number one. Number 2. Number 4. And then
five, you don't remember five?
Oh no, never got it. Goodness of fit for each model. What does that mean?
That's the one on number 5 they told us don't do.
He
He
said
said
don't.
it doesn't make any sense to do it.
He said
It
don't do that
doesn't?
one.
On number 5, right? Like the actual application 5.
No,
I'm talking about forward number 5.
app 4, number 5.
Oh, that's the variability thing, right?
What does he mean by goodness of fit?
here, you slide number 20. You can flip it to the other one.
Oh, well, maybe that's what he's talking about. Not application 5. Okay, yeah, he said don't worry about that. That's the goodness of fit thing that he was talking about.
Is that what you said? Don't worry about it.
That's what I thought y'all were gonna say that, right?
Yeah, because how are we supposed to say what the goodness of fit is?
Exactly.
Without.
Yeah, he said it doesn't make sense to do that. I thought he was talking about application number 5. He's
So y'all
talking
just
about question number 5.
Gave all the R squared values?
I did.
We did put the signs in here, right?
Mm-hmm.
Here we go. Y'all think this will be
Done in
still?
10 minutes.
Thank goodness. But he said try.
All these things, yeah. Yeah, that there's never should have been 31 different things. I cannot believe that. That's just a
Oh, he can royally fuck himself for putting number 5 in there also.
Alright, so for the last one, the social whatever, negative 0.05003 times x plus 0.8358.
Plus 0.8358.
Yeah.
Thank you.
On number 5, why? Why is he doing this?
We'll see.
There's 3 different ones.
He's talking about for each one, what's the likelihood that age affects its variable?
I'm talking about for the next.
Oh,
Yeah.
you're already done. Is what you're telling me.
I just finished.
Once you're done, please bring your team applications and turn them into me. When you're done, you still have 10 minutes, but when you're done, please bring them to me.
I'm not gonna finish this.
I say we just staple it all together.
They are still individual, but I'm saying all the applications from your team. That's what I meant, all the applications from your team. Just bring them to me.
This first and then this first and then this first. You want to go out and divide and conquer?
It's gonna take forever. I'm probably gonna enter it wrong. I'm dyslexic as fuck.
Yeah.
The third one, we're going to divide and conquer.
She's not there yet. Are you on the last tab already?
The last, like, I'm on the SOC of application.
Oh, okay.
Sorry. It took me a while to input all these values.
I hope it's gonna be on the skill assessment for lab. If it is, it just need to be less value.
No, he's just going to give us the values instead of us having to type it in. You're just going to have to be able to determine it.
You know how we have skills assessments and exams? That's what I'm hoping, like this calculator not pulled up and we get it 40. But I love to do screenshots.
You know, we put the X's and X and Y's and Y's. Let's flip it on this one.
Yeah, he flipped it to messenger.
Good call, because I was not paying attention.
While you're still working on this, I just wanna, answer a question that I haven't been asked yet, but I keep getting the same question every time. How is this gonna be on the exam? For this, last year, I gave them an output, from the same software or online calculator tool, an output with the same parameters being reported, some of them, and then I'm going to ask you questions. You have to know what is the slope. You have to know what is the regression coefficient from this data. You have to be able to make the determination if the relationship is statistically significant or not, based on either the p-value or the confidence interval. I may not show you both. You have to be able to make predictions. If I give you a value, you have to be able to make predictions. Or, let's say, if I ask you like an S question, what is like the Y value for an X value that is 37 or 27? If I ask an open-ended question, you have to look at the data and see if you can actually make sense to make an extrapolation and calculate or predict from this data, or if this value, X value, is outside the range, and you should tell me, this value is outside the range, I'm not going to be able to calculate Y from that, like what you have done today. These are the nature of questions you're going to get in addition to some theory questions about linear regression and correlation in general. That's all they have in mind for that. Still waiting for everyone to be done in like 7 minutes. I'm going to start going over the slides quickly before we leave.
There's 30 total,
Accomplish the
right?
same thing with 10.
Thank you. Hell, I did this a long time ago with this.
It is also guaranteed in the exam that I'm going to give you a case study, and ask you what is the appropriate statistical test to use. Just what is the test, the name of the test to use in this case. And it could be anything of what we have covered, linear regression or something else. As an essay question, just write briefly the name of the test. Simple linear regression, multiple linear regression, whatever test it is, because you should be able to make this determination once you see a study.
Right, let me see if I'm on the right track. I ain't gonna call it out. I'm gonna just say, thank you.
Was that the first one?
No, second.
What was the first one?
She has it.
Oh.
Nita has it.
You did you get point?
Hold on, she's getting it. She's talking about
Point 4061. The first one. I give up. I can't enter this shit to save my life. I did that 3 times. I swear I'm dyslexic. I have to be.
I'm doing something again. My life. But I did it right the first time.
Give up.
get your paper? Okay.
Okay. This boyfriend?
The first one, second one.
So this will be significant because they have zero.
No, I don't have zero.
So
Zero's
it
not
will
in
be,
there.
so it will be significant because of the.
Yeah, no, significant. No.
Y'all doing the third one right now?
I already did it. Or I've got the values right now.
I think I've entered maybe one out of all of this right.
Are you going double checking?
Yeah, I swear I'm dyslexic. I have to be.
That's the second one.
Like, it's making me go cross-eyed.
Okay, so if you're still working on the application this time, it's fine. Keep working on it. But for the sake of time, I'm gonna go over the slides. Just please work on it quietly. If you wanna turn in your application, you're welcome to do that here as well. But I'm just gonna debrief. I have a debrief and just wrap it up with you to reinforce some of the concepts that we have covered and see if we have missed anything that's important. Some of it we'll go quickly over because we already covered it very well. So again, correlation analysis, but why please? Correlation analysis gives us two pieces of information only. Strength of a relationship and the direction. Strength, it's between, as we said, -1 to +1. The closer it is to 1 or -1, the stronger the relationship, regardless of the value itself. The direction, positive or negative, we talked about that already. And the units of x and y are irrelevant, as we said, because they can have completely different values, like the first application, the was weight and blood glucose level. Again, it provides information about association, not causality. You cannot say that weight is or higher weight can cause a higher blood glucose level. You can just say they are associated, but you cannot necessarily jump to conclusions about causality with correlation or any of the other types of regression. So, what is different from regression analysis again? It's that you can use the straight line equation to estimate or predict the values of y based on known values of x. That's a major difference between regression in general and correlation. So suppose a researcher is interested in the possibility of a relationship between percentage body fat, the example in the reading, and the number of injuries among a team of hockey players through the course of the season. Correlation analysis would just answer the question, how the changes in the values of one variable affect the other. Is a small change in percentage of body fat related to a small or large number of injuries, and depending on the correlation will be positive or negative. That's all what it can tell, but it does not give us a specific value. And as you have done today in the applications, that's what the researcher exactly did. They collected the percentage body fat from 8 players, that's just a subset of the data, and the number of injuries in the season, and then they put the dots on the lines on the graph, and they established a straight line. So remember that the relationship was r equal -0.7 is stronger than 1 was +0.5. The sign has no meaning because some of you still got that confused on the red today. So again, there are several formulas to calculate correlation, but the most common one is Pearson's correlation. These other ones, you should just be familiar with the names. If someone told you that the data is not normally distributed, there are lots of outliers and extreme values, then you use what's called experience rank correlation. And when the data is ordinal, remember ordinal, it means that it has some order to it, like weak, moderate, strong, or if we're talking about levels of education, then you use Kendall's rank correlation. If a researcher used any of these in a paper, they will have to specifically say that. If they don't mention them, then they use Pearson's correlation. I'm not going to test you on that. I just want you to be familiar with that. But in any test we use for correlations, it's Pearson's correlation. So what is the null and alternative hypothesis for correlation? The null hypothesis is that there is no correlation. There is nothing going on here, which means that R equals 0. The alternative hypothesis is that there is some correlation, even if it's weak, but it just means that R is not equal 0. How do we determine the statistical significance of the R? Using the two approaches, either the p-value for the correlation coefficient, if the p-value again for R is less than alpha, then we reject the null hypothesis, and vice versa. For the confidence interval, remember, if it includes 0, it means that it is not statistically significant, because it is possible that R would be 0, and that means there is no difference. So some of you today were wondering, okay, so we calculated an R, and you asked us to determine if it's what is the strength of the R or the correlation here. And again, there is no gold standard for that. And if you ask me, I might even see these categories, although they come from one of the top journals in the world, that they are still arbitrary. But each journal has their guidance or guideline for determining that, and you just have to stick to it. These guidelines, for example, are taken from the British Medical Journal. But of course, if I see an R of equal 0.8, I'm going to have to say it's really strong. Under any guidelines or using any guidelines. If I see an R equal 0.3, I'm going to definitely say that it's weak by nature. I'm not going to ask you any of that, of course, in the exam to determine the strength of an R, because this is very subjective. So back to the example again, they found that the percentage body fat and number of injuries are strongly correlated because the R was almost equal to 0.8, and the correlation was statistically significant because the p-value was equal to 0.001, which is less than the alpha. So what do we know so far knowing that? It means that as the percentage body fat increases, the number of injuries increase, and that's it. If we're just doing correlation, that's it. You cannot say or conclude anything else. Excuse me. What we don't know is how much increase in the number of injuries can be expected with each unit increase in the percentage body fat. Meaning for each 1% increase in the body fat, how many additional number of injuries are we going to observe? And that you cannot answer from correlation. You have to do regression analysis to know that. So we talked about the different uses of simple linear regression versus multiple linear versus simple logistic and multiple logistic, and we'll discuss logistic regression by next time. But I want you to really be comfortable determining the appropriate statistical test of any of these in a certain situation. And as I told one of the teams here, the best way to do that, trust me, is either you by yourself or with the team come up with examples for each that you can apply these analyses to. So you establish, once you have all these dots and you plot them here, you get something that looks like that. And this is called a scatter plot. This is very important as well to know. This is called a scatter plot. And you can tell visually, even without running any further analysis, just by drawing the data, that well, this is kind of a strong relationship, and it's probably positive. This one, the data is scattered like everywhere, and it's kind of a weak relationship. As a researcher, I wouldn't be willing to investigate any more in this relationship. I'm not going to calculate anything because the data is just arbitrary and scattered everywhere. So you know now what is a linear regression equation, and again, it can be, don't be confused confused if I show it to you in this format or this format. This one, the intercept first. This one, the intercept is at the end. And all what you need to know is that this number that's close to the independent variable, this is your regression coefficient or the slope, and the other number is the intercept. So this was the linear regression equation for the example in the reading. And just for your information, you're not gonna do that or be questioned about that, but I want you to know how the software actually calculates this line. Because you know, this line actually could be here or there, because it doesn't actually fit all the dots, the data points on it, right? And the software will always force a straight line no matter what. It will find some pattern and just force a line. How does the software do that? By just calculating the distance from each of these points first to the line. It actually draws like 1,000 or actually 10,000 lines before it draws that one just in the background, and then evaluates the distance from each dot or data point to that line, and then they sum that distance and add all the sum, and the line that actually gives the software the least sum squared distances is the line that wins, and the software actually shows to you. So again, there are probably like hidden, there are like 1,000 lines that the software tried to draw here, and then it calculated the distance from each of these dots to the line, and then summed that distance and summed all the summed distances, and the least sum square is the line that wins. And that's the best line according to that. So again, just know that this is called the least squares method because it squares all the distances from the dots to the line, or called also the least squares regression line, and that is the line such as the sum squared distances from the data points to the line are minimized. So whatever the number that minimizes these sum squared, that's the line that wins. But again, you don't have to worry about this. This is done by the software. I initially said large number by mistake wins. If I said that, that's wrong. So it's a minimum number. So we're trying to minimize the distance between the dots and the lines. That's what we're trying to do. Okay, so what does this mean again with this equation? So okay, we got our linear regression equation in the example about the number of injuries and percentage body fat. Again, what does it mean? It means that on average, for each unit increase, which is 1% increase in body fat, there is the amount of the slope, which is 0.8, about 0.8 increase in the number of injuries. So let's say, just hypothetically, if the number of injuries for 1% fat was just 1 injury, then if we have 2% body fat, it's going to be 1.8. That's what you expect. And if you want to calculate it for 6%, you multiply that number 0.8 by 6, and then you will get the additional amount of increase in the number of injuries. That's basically what you're doing when you try to predict y from x. So it's very important not to extrapolate beyond the range of the sample data, as I explained to you today. So you have to see what is the minimum value in your data, in your x's, and what is the maximum data. You can predict y for any x that is in this range, within this range. It doesn't have to be in the table, but just within that range. So the range was from 1 to 10. You can predict 2.5, 6.3, but you cannot predict 11. You cannot predict number 5. That's what it means here. Because again, sometimes it mathematically works, but it doesn't make sense biologically. Okay, now simple linear regression. Sorry, we do not talk about correlation coefficient. We talk about regression coefficient or slope. And by the way, some of you have asked if the regression coefficient should be the same as R, or correlation coefficient. You will see that sometimes they are the same, sometimes they are not. So don't confuse yourself. Just call the regression coefficient or slope a regression coefficient, not a correlation coefficient. The correlation coefficient is separate. Sometimes they will be the same in certain circumstances, but don't worry about that for now. You just focus on simple linear regression separately from correlation coefficient. And basically, the null hypothesis here is that there is no correlation, but you look at the slope. If the slope is equal 0, means 0 multiplied by x equals 0, then there is no correlation. It's going to be just y equal the intercept. If there is a difference, then the slope shouldn't be 0, anything but 0. And that's why when you try to determine the statistical significance, again, you either use a p-value for the slope, or if the confidence interval for the slope includes 0, then it's not statistically significant. The same as for the correlation. Okay, now I asked you about something called the goodness of fit, or the model fit. This is a statistical term that would be provided by the software, which is R squared, the coefficient of determination. Basically, again, in this example, I told you that we were trying to establish an association between weight and blood glucose. But it could be not the only factor that, again, affects blood glucose. In fact, some of the researchers, when they are studying more than one X, let's say weight, blood pressure, age, what they do actually, don't have to memorize that name at all. What they do initially, they do what's called stepwise regression. What's a stepwise regression? They basically enter one of these at a time, one of these x's at a time, to see which one would show potential to actually affect the blood glucose. Because if they enter one of these variables and try to establish a correlation with blood glucose, and they find that it's very small, the R square is very, very small, then this factor does not explain the changes or variability in the blood glucose. And they keep doing this with all the variables until they reach one or a set of variables that they think they can build a good model. So the good model can be built from one variable or more than one variable. So let's say that in this case we found that weight is the only hypothetical. I know it wasn't. Weight was the only significant potential factor that actually cause a change or variability in blood glucose. Then that's your perfect model. That's a model that has goodness of fit. How would you know? If you try to analyze the relationship between weight and blood glucose, you would have a high R square as close as you can to 1. Again, I told you hypothetically, if it's equal to 1, it means that this is the most perfect relationship in the world. That in all the changes in the blood glucose are 100% explained by this factor. But what if R squared was just 20%, or 0.2, or 20%? This means that weight accounts only for 20% of the changes that happen in blood glucose, and it means that 80%, the missing 80%, are accounted for or explained by something else. This something else can be another variable, or it could be random error, or measurement error, or something else other than weight. But all what we know is that weight only accounts for or explains only 20% of the changes that happen in blood glucose, which means that we're missing a lot, and that's not a good fit model. Sometimes we call it goodness of fit or model fit, or sometimes we call it lack of fit as well. So I just want you to focus on this slide and understand the concept and understand how can you determine the model fit or goodness of fit using R squared. Okay, so we already covered that too now. Again, you can R squared is the square. So you can calculate R, as the square root of R squared. And in regression analysis, it is more informative to report R squared. So in correlation, we report R only because that's all what we have. But in regression, we actually report R squared. If someone want to report R as well, that's okay. But you can always calculate R from R squared, but I would blame them if they haven't reported R squared. Because that's what really matters. Because R just tells me about the correlation, but it doesn't tell me about the how much percentage this variable, the X variable, accounts or explains the change or variability in Y. So just remember that in regression analysis, R squared is the most important element to be reported. In any relationship, there will be outliers, always. There will be that guy who deviates from the norm. And the question is, actually, so if you actually ask the software to draw a line, this wouldn't be the line in fact. I will show you in a minute how would the line be, because this guy, the outlier, would actually regress or draw this line down like that, and you probably wouldn't find any correlation based on that, just because one person was outside, the norm. So what do you do when you see an outlier? The first thing I do when I see an outlier, I actually check the data. I know some of you are not happy with the data entry and all of that, but it's okay. You will appreciate it maybe later or not, and that's fine. But this outlier, first thing I do, check the data, and you would be surprised that sometimes it's just an error in the data, just a mistake. Once you fix it, that's it. Sometimes it's a real outlier, like someone who scored like that. And the question is, what do you do about them? Are these outliers, or are there similar outliers in real life, in different populations, or was this just an instance? If it was just an instance, maybe you can actually exclude them and just report it transparently that you excluded them, and why did you do that? Because they don't exist in any other samples or in the population in general. So I'm not going to discuss today whether you're going to exclude an outlier or not and what you do about them, but what's really important, and that's a fact, is that you have to report what you do with them transparently. If you exclude them, you have to say that you did that and why, and what was their score or number or data point. If you keep them, you have to justify why did you keep them and carry the consequences, of course. So again, the software, no matter what, will always try to force a line. If you have scattered data like this, remember in the first slide when I showed you scattered data, it didn't make sense to me. The software still, forces a straight line, but it gives you an R-square of only about 14%, which means that only 14% of the variability in the number of entries is accounted for or explained by the percentage of body fat. It means that I'm missing about 86% that I don't know, why these, why the change. 86% of the time, I don't understand why the number of injuries increased. It's not about body fat. Okay, remember that no matter how strong the correlation, it's an association, not causation. That's just a fact. And that relationship cannot be reversed. So do not confuse the relationship between X and Y. This is really interesting. And assume that you can draw the same conclusion reversing the positions of X and Y. It might seem plausible. We say, well, increasing number of fat, number of body fat increases the number of injuries. How about we say increasing the number of injuries increases the body fat? Does it make sense? It doesn't. It just doesn't make sense. So do not assume that you can always reverse the correlation, since they do not have units, and since we do not do any predictions. Sometimes it just even doesn't make sense to say it like that. And if you do not have any questions, then that's it. Thank you.
I actually do have a question. How did you guys answer
If you have not turned in your application, please
it
do
says,
that
would
now.
you use correct to check or measure? I mean,
So yes, but I don't
in the first one, under just warfarin, I wouldn't. They're not strongly correlated together. I mean, it's only at 18.70%.
I'll say yes for all three though.
Same with the warfarin.
What you do all weekend?
Stronger.
The warfarin and the heparin, and then the warfarin and the enoxaparin.
Yes, or
That's the strongest relationship.
That's the strongest relationship. I would say yes.
I said that one. I just ranked them. I said you can use all
I
three.
am for warfarin and then yes for those two because the percent, because this one is a very weak correlation.
Yeah.
I
Or at
agree.
least that's what I said.
Number 6.
But I mean, I don't really know what he's asking. I don't know what to look at for that because they're statistically significant that they, have
But
a
it's
relationship.
asking if you would use it in each three.
Yeah.
I would use it.
So if they're given three different, strong, a weak, it's too, like if they were all strong, maybe I would.
Right.
But we have a moderate
I
correlation.
used all three.
a weak correlation, but then you have a strong one. So do you do it for each instance, or do you do it overall? No, we wouldn't use this.
I'm gonna say no.
I said overall you could use all three, but then I ranked them. This is the strongest one I recommend. The second one, that's
So why did you say yes to all three of them when it's only an 18% chance that they're correlated?
I just figured the p-values are significant, but
And see, that's where I'm getting my hold up. Like, it states that they're significant to have a correlation. But
I mean, they all three
as
work.
for a variability due to that,
it might
this
just
is really low.
work because of something that we don't understand, and that's fine as long as side effects aren't. There's lots of drugs that say mechanism unknown, I guess, that work. I just recommended all three and said we have a lot more evidence to back this third one up.
Here, I'm gonna go talk to him and just ask him about p-value versus that order.
Yeah.
We use the square root of this number. And so we use the number 3 to come up with the correlation.
I think maybe would.
Overall is yes.
Yeah.
Overall, because we got 43%, 65% in units, 96%. So overall, I would go with yes, because if we're using that one table.
I know they're all significant and they're all gonna give you results. It's just one of them we understand the most about the relationship.
Just say yes, they're all statistically significant.
That's what I said, and then I ranked them and said this one has the most like evidence with the relationship between its correlation. Which is stupid.
Is it the relationship between dependent and independent or statistically significant? Is that what it is? Slap that no.
Right.
Yeah. That was just basic word.
It's a write-up for IP. And what you see, it's a... It's 30 good idea.
You think I should just do this or wait on my CD?
You can try it. I'm not writing that yet. I'm done. I'm doing this to be able to go back into playing for half an hour.
The Kim's gonna be fun. I haven't really read it.